I'm going to do the same thing. We're going to walk through this question, and I'll stop anytime we need to put something down and try and add some information onto what we're writing. P and Q are ends of the diameter of a circle. Stop. The sentence doesn't end there, but that's enough information for me to start drawing something. Okay, so I need a circle.
How do you draw
There you go.
How do you do
Okay.
that? Such a cheater.
Actually, I literally am cheating because it's much easier to draw big circles than like small circles because I'm using the I'm using my shoulder as a it's a anyway. So
Ali's circles.
which just barely scrape the definition of what is a circle. There's my circle. I need a diameter, right? Now, it's tricky sometimes to remember what all of the different words mean. You've got a lot of terminology there. Diameter, what are the other kinds of words you see?
Diagonal.
You see radius, what else?
Diagonal.
Circumference. Now, I think those are the main ones, aren't they? Now, here's the way that I try to remember which is which, okay? I think the diameter is the easiest one to remember because you're very familiar with another word which has dia in it in geometry. Namely,
Diagonal.
diaphragms are useful, but I'm thinking of diagonal or Diagon Alley. But anyway,
Diagon alley.
so for instance, here's a parallelogram, right? Every quadrilateral has two diagonals, but where does the diagonal go? Okay, here's one of them. Okay, now I could draw in the other one, but you only need one to see. A diagonal is a diagonal because it goes all the way across the shape, right? It doesn't like stop at one point here. It has to go all the way across between the angles, right? Dia means across, okay? So therefore, a diameter means all the way across the circle, right? Now, it's important that it's all the way across because it is not this distance. It's not this distance.
Hang on.
Right? You're like, that's a cross, right? But it's a chord. It's not all the way across. Just like this, that's not a diagonal. That's just some random line, right? So a diagonal is all the way across. A diameter is all the way across, okay? To make sure it's all the way, it has to pass through the center, okay? That's a diameter. The circumference is also very easy to tell from the name because it literally has the word, it almost has the word circle in it, right? It means to, like, encircle, to go around, right? So that's this whole distance around here. That's the circumference. And that leaves the radius, which is, what distance is the radius?
From half.
It's half of the diameter. It's from the center.
Which is 10
It's this distance, and they've told us that's 10 centimeters. Okay, now, I've drawn up everything that's on the first sentence in the question. P and Q are ends of the diameter of a circle with that radius. So far, so good. A point's chosen at random on the circumference of the circle. That's just like the previous question, isn't it? So somewhere on this circumference, not here or here, has to be like somewhere on the line. They pick a point. Find the probability. Aha. Probability. Okay. So what's the fraction going to be? It'll be, just to do it in shorthand, favorable outcomes over sample space, okay, or total outcomes, if you like. Now, my task now is to work out what the favorable outcomes are and what the sample space is. Okay. Find the probability that the points within 10 centimeters of either P or Q, all distances being measured along the circumference. Okay, it's a long sentence, so let's try and put it all together. One at a time. 10 centimeters from P, but measured along the circumference. So for instance, a point like this, right? That's not going to be chosen, right? It's not going to be chosen. A point like this could be chosen, okay? When they measure to get there, they're going to measure along the curved circumference, all the way around. Okay, yeah, so it's going to be curved around. Now, how far can I go? I'm allowed to go 10 centimeters on either side, right?
Wait, so you can only go along the regular circle?
Yeah, that's right. So there's one lot of 10 centimeters. I've just drawn it so it's roughly the same as that, okay? And in fact, this question here is kind of like this question, but taking this interval then like wrapping it around a circle, right? It's that question, but making it round. Yeah? So just like you can go one side, you can go the other. Okay? That's another 10 centimeters. And they say of either P or Q, right? So everything I've got over here, I'm going to draw the same over here. So there's 10, right? And here's the last 10. Okay. Now, do I want to be close to P and Q, or do I want to be far away?
Within.
Find the probability that the point is within 10 centimeters. So this is the opposite of this question. Here I wanted to be outside. Now I want to be inside, close to P and Q. Okay. So therefore, the favorable outcomes, right? 10, 20, 30, 40. There's 40 centimeters worth of favorable outcomes. Okay? Now, to finish off the question, I need to divide by the sample space. Right?
Is that 20 or 10?
What is 20 or 10?
The sample space.
Okay, well, how do I, what did they start off saying? A point is randomly chosen from where?
10.
Is that what the question says?
So a point is randomly chosen on the circumference of the circle.
On the circumference. Anywhere on the circumference,
Anywhere
right?
that choose, I can.
Yeah, up here, that's fine. Up here, over here,
Even over there.
they're all fine, right? So I got to work out how long this thing is. I need to work out what is the circumference of this
360
circle.
degrees.
Okay. Now,
Is it?
there are two formulas that tell us about circumference and area. Circumference and area, and they look very similar. Let me show you.
Sorry, I meant 360. No.
Too high.
Yeah, 2 by out.
Okay, now there's these two formulas, right? And they are very, very close to each other. The question is, one's area, one's circumference, which one is which? And how can you tell? Ali,
Because area.
which one's area? Which one's area?
This one.
This one?
Because in the C, like the square, and all area answers are in squares.
Good. Okay, so for instance, an area might be like, I don't know, 10 square centimeters. Right? Areas have to be square because it's a two-dimensional thing. Whereas the circumference, there's just one R. It's one dimension. It's a length. Okay. So good. Therefore, the circumference is 2 pi r. What's r? The radius, which is 10. 20 pi centimeters, I guess. Okay. That's the sample space. That's the sample space. 20 pi. Okay, now, over here, when I'd gotten to here, I said, could I simplify? Right, and the answer was no. Can I simplify here?
Okay.
Yes.
I can simplify. I can simplify quite a lot, actually. What's the common factor I can take out of both?
Oh, right.
What's the common factor in the numerator and the denominator?
10.
2.
10.
Go bigger, go bigger.
10.
Come on.
20.
Go bigger. 20. You can divide that by 20, you can divide that by 20. Right?
2 over 1.
2 over pi. See that?
2 over pi.
2 over pi.
Wait, what?
That's a bit weird. Why is there pi? That's a great question. Where did it come from?
Because there's like the 20's gone and then the pi's like there and then she did pi.
It came from the circumference.
Also, it stays with it.
The circumference has got a pi in it. So therefore, our probability will have a pi as well. Now,
Oh, so the
If-
pi is just. Oh,
if you're interested, you can work out what that is. You can get a calculator, right? And you can say, what is 2 divided by pi? I don't know what it is. Let's find out. 2 divided by pi. And the decimal you'll get is 0.6366619, and it keeps going. Okay, so there you go. They didn't tell you you had to approximate. Sometimes they will, but so that means this answer's fine. But if you're curious, that's what the probability is. Okay.
Will they ask you, like, if it, don't give the answers to.
They'll tell you what to
How
do.
they say that?
Okay.
Like,
They might say, for instance, provide your answer to 2 decimal places, in which you would say, that's, well, how does this round off?
0.63.
Now, you always got to, when you're thinking about rounding, you think about the digit you're chopping off.
I mean 0.
So if I go 2 decimal places, I'm going to chop off the 6. Is 6 big or small? It's big, so I'm going to round up to 6/4. Okay. Alternatively, they could say significant figures, and you know how to do that. Now, maybe I should have said one more thing. When we're talking about the different attributes that these questions have, this is hard because, you remember we got to here, right? We wrote down the favorable outcomes, but then when you got to sample space, you were stuck. What did we have to do at this point?
List all the
Possible.
What? We had to go to the circumference, didn't we? Right? So that's why this problem, it brings together, it combines more than one topic. Right? You thought it was just a probability question. I did it as a probability question, but then you need to know stuff about circles, and it sticks them together all at once. As you look later on, you'll have to do probabilities and areas, right? And it's the same kind of idea.